All right, so let's start with pop. And we'll put it right underneath push just to keep similar methods together. What does push need to, what does the signature of push need to be? It needs to return an E. No, pop, not push. Pop. There we go. Doesn't take any arguments, and it does something. So what do we need to do? We need to return the data at the front of our queue, so data sub front. But we can't just do that because we need to increment front using the same tricks that we did when we were incrementing rear with push. So let's start by saying eTemp equals data front equals next index front. Return temp. Considering how complicated push and all the other methods were, that seems remarkably simple. Do we think it'll work? Let's find out. Spin that up. My array q.pop. We'll do that twice to be consistent with the example on the board. And I'm actually going to add this statement here because I know that as soon as I try to add 12, it's going to overflow and change the size. But I want to see this state where it's kind of wrapped around. What's going on? Oh, right. Of course. Data is an array of objects, so we need to actually cast that to an E. We know it is an E because that's the only thing we can push onto this queue. And we need to add that that annotation to say, yes, I know this is unsafe, but I'm making sure that it's actually safe. So that's accomplished using at suppress warnings unchecked. Now we should be able to compile with no problems. Go back here and run it, and we get a array index out of bounds exception. Which means we actually had an issue in ensure capacity before that just didn't get triggered. So let's see where that happens. So we have an empty array. I'm going to change the order of these print statements, or add another one, because there's a state we're not seeing here. Okay, so we start out with an empty queue, push a whole bunch of stuff onto it. pop these two elements, and then this should give us an indication of something we forgot to do in pop. Which might actually make our error go away. We incremented front, but we're also changing the number of elements in this queue. So let's add that. Num items minus minus. And now it runs with no issues. The problem was that we were subtracting some number from many items, which was not accounting for, or num items rather, that was not accounting for how much space was actually left in the array. So we were trying to copy more elements than were actually there. So now we see empty array, push a whole bunch of stuff onto it, pop two things, and the queue is reflected appropriately. Still the same capacity, just fewer elements. We push 11 and 12 onto the queue. No, 10 and 11 onto the queue. We are now at capacity. Front is at index 2, and rear is at index 1. So it has wrapped around, just like we have in this diagram on the board. Front is up here, rear is down here, so front is 2, that's correct. Rear is 1, that's also correct. Then we add 12. We want to add 12, so we end up with this array with the second half of the original array stuck at the beginning, the first half of the original array stuck at the end, and then 12 added onto the end. So now we have front is 0, rear is 9. Yeah, that's correct. We have 10 items in the queue, and its capacity is 19. Any questions on that? Let's implement a peak method. And I'm going to put that right here. So, how is peak different from pop? Line 37, we need in peak. Line 38, we're not removing anything from this queue, so we don't need line 38. We don't need 39. We do need line 40. We need to return something. However, lines 40 and lines 37 can be combined into one line, so I will do that. We do need to suppress warnings because we do have a, in theory, unsafe cast. And that's it. That is the entirety of our peak method. Any questions on queues? Yes. And with that, we conclude the material for the exam. So we have um, basic Java concepts. We have um, iterators, iterable collections, um, generics, how to use them and how to write them. Um, and we have 3 specific data structures. We have linked lists, we have stacks, and we have queues. So now that we've talked about queues, are there any other questions that you feel there's a gap in your knowledge in preparation for the exam? So, Dion, you've taken one of my exams before. Do you have any recommendations for your classmates to prepare for my exams? There were multiple choice on those tests, but the final had short answer, right? I wasn't lying. That is true. In his class, I tried having a programming portion of exams. That was a bad idea. So that I've decided I'm never going to have an in-class programming portion of an exam again. I also don't like what you've experienced, which is writing an entire Java program on an exam. Java code is good to know, but not something to write down. Yeah. So now the other class, the 1150 that I'm teaching this semester, I was originally planning to give them an exam tomorrow because of the way the semester worked itself out. Of course, I didn't realize that tomorrow was a holiday. So they ended up with a take-home exam, so they do have to write a Java program for their exam. I think you guys will be happy not having a take-home exam version of this exam. So hopefully on Thursday everything will go smoothly, and my plan is that this exam should take an hour and 15 minutes, and then we'll talk about it for the remaining hour and 15 minutes. If it looks like that's not going to happen and it's going to take longer, I don't expect it's going to take me an hour and 15 minutes to talk about the exam. So we will. I'll allow more time if it looks like people are going to need it, and then we'll talk about the exam in whatever time is remaining. With that, if you are still shaky on any of the concepts that you think might be on the exam, definitely come talk to me and hopefully get less shaky on them.